Do a little run through of our practice test we posted last week for the upcoming midterm. Again, I would really urge you to, before watching this video, to do it yourself and see if you can answer these questions. So let's just go ahead and get started. Of course, with the test, I'm going to read the introductory material here, make sure I understand what's going on in the test. Nothing too interesting here. So let's start looking at the first question, using methods. So this is basically how do you call a method. Assume you have a .java file with a static method that starts off like this. Looks like it's a min method. What do you have to pay attention to here? Well, there's a couple things I would pay attention to. One is what are the number of parameters and what are they? Like what type are they? They're both ints. There's two of them. What's the name of this thing? And then notice this is a static method. And a static method means we call it without any object attached to it, right? So down here, I'm going to call the min method and pass in val1 and val2. Because you're supposed to find the smaller val1 and val2. And I need a semicolon at the end. So that's all there is to it. It's not really a trick question. But I would urge you to think, okay, what's the other possibility here? The other possibility is that I have some kind of object with a not static method. So something like char_at for string or something. And how do you use that? So you might want to think about that option. Let's look at the next one here. Each of the following code fragments contains one compiler error. So basically, that doesn't mean it gives the wrong answer. It means it's not even going to run in the first place, right? Circle the line, number the line of code that would cause the error. Choose one that changes the intended meaning of the code the least. So here is the example. This is not, the problem. This is something that shows you how you're supposed to do it. It's a one-line program, of course, and there's a misspelling here, so that wouldn't compile. And so I circled the line that the error is on. And now we have our actual problem. This part here, this massive 4-line program, and somewhere there's an error there. So what's the point of this? Well, again, Eclipse will tell you these kinds of things. Sometimes it gets confused, right? And if there's multiple errors, it kind of starts making everything wrong, or you can kind of get off cycles. You still have to have some ability to sort of understand yourself what could be wrong. And as you write code, it's good, of course, to write code that is actually syntactically correct, so you're not constantly having to go back and fix stuff. So first line, okay, we're declaring a variable count. We initialize it. It has a type and a semicolon on the end, so that looks pretty good. Now we have an if statement. We have if parentheses. This all looks good. And of course, the thing that maybe occasionally gets people thrown off a little bit is here we have an equal sign instead of the equal sign. And this thing here should be a Boolean expression because it's in an if statement. And actually, this thing actually produces an int. I don't know if you know that, but if you say count equals 10, this thing actually evaluates to 10. So you can use it in expressions. I don't like doing it too much. It's confusing. This is an assignment. Just let assignment work. But in some contexts, this makes some sense. So anyway, that's wrong. I'm going to circle the line it belongs to 3. All right, not too bad, right? But of course, finding errors yourself, is a little painstaking, right? You have to look carefully at this stuff and not assume like, okay, looks good, but actually think about what makes a valid statement and so on. For each of the following loops, so there's only one of them, give the number of iterations executed. So again, what's our goal here? Well, we are trying to act like the computer. And what does number of iterations means? It means the number of times the loop body executes, right? So that's, again, the key definition there. Here we have a for loop. And again, it's a little bit, it's not in the standard form, starting at 0, going up to less than the number of iterations. Add 1 each time. But people do stuff like this, and you need to be able to figure out what's going on here. So what do we start off? Maybe I'll write up here. I is 10. All right, we initialize like that. We check is 10 greater than 0. That's true. We print out. I'm going to have, again, I like to kind of put off here how many things print. So I is 10. We print out 10. Then we subtract 3 from it. So I is 7. 7 is greater than 0. we print out 7, we subtract 3, so we get 4. We print out 4, we subtract 3 to get 1, we print out 1, we subtract 3 to get -2. -2 is not greater than 0. We do not execute that loop. We go on to the next statement here, and I can count how many times I printed something out, right? That's how many times the loop body iterated. So 1, 2, 3, 4. 4 iterations. Clean up all the mess, right? But again, it's important to have some strategy for keeping track of this stuff, and again, some strategy not for just keeping track of I, but for keeping track of how many times the body executes. And so that's why I had that extra line to print things out, because I want to be able to, count those out and not just sort of in my head keep track of stuff. It's very easy to get confused, and it's really good to write stuff down for this. All right. Another thing that we have to pretend to be the computer and execute here. For each code fragment below, track how the code will execute, write the output that be generated. And again, all these things in the test, assume it's part of some class, it's part of main, it's part of something. We're not trying to be so tricky that everything's just like, it doesn't compile because it's not in, not in a main method or something like that. All right, so again, we need to just sort of work through this and make sure we understand what each part is doing. So, okay, x is 2, y is -2, that's fine. If x is less than 5, is 2 less than 5? Well, that's true. Is y greater than 0? -2 greater than 0? That's false. So if we have a true or of false, what does that equal to? Well, with or, if anything there is true, the whole thing is true, right? So this thing evaluates to true. If that had been an and, then it would be false, because and requires both those to be true for it to be true. Okay, so x then gets multiplied by 2. 2 times 2 is 4, so x is now 4. We skip over the else, right, because the true part executed, and I print out x, 4, comma, y, -2. All right. Again, I'd say the only thing to pay attention to here are these sort of compound Boolean expressions. You actually, if you just say it out loud, it's sort of easy to get yourself a little confused. Is it true or false? Is actually and write down what each little subpart is. This part is true, this part is false, and then just apply the rule. Like if anything that's true, the whole thing is true, right? Don't try to kind of turn it into some English sentence that then you evaluate, because we're a lot more casual with this stuff in English than we are with computer programming languages. All right, describe the method. What would be the best name for this following method? Okay, so this is a weird looking method, right? And it says rename me. And in fact, there's nothing in here probably that's going to be designed to give us a hint as to what's really going on here. So we're making an array. It's not like it's saying something about what that array is. Here we have this variable called 0, like that's, it's just 0. And we're adding some stuff up. So, what is the purpose of this? Now you might say this is like a ridiculous kind of question, but to be honest, even people that write code and name their method something, half the time you still need to really figure out what's going on in there, right? It's not like they didn't do a great job naming the thing, and maybe the documentation is kind of limited or something. And so you have to kind of probe it a little bit and try to kind of reverse engineer what that person was thinking and what the goal of this thing is. And so, again, this is a skill that is not, is important, because you're using some other code, and you need to figure out, do I want to call this thing, and what do I expect to come out of it when I call it? Okay, so anyway, we're making an array that's the same size as number. All right, so that's interesting. So here the suggestion is let's try putting some numbers in and see what comes out. So that's one thing you can look for a pattern here and then work from that. So I'm gonna try to put it in with start off with a 2 here. So numbers 2. So I make a new int array, and when I make an array, it actually default initializes the elements of the array to sort of like a whatever 0 kind of thing is. That's zeros for ints, 0.0 for doubles, and actually it's null for objects. So if you have an array of like string, for example, it's going to be no object, not an empty string, which is a big difference. All right, so okay, then we have this return value 0 for int 0, pull values out of array. So this is going to pull out a 0 and put it in 0, and then pull out this other 0 and put it in 0, and it's going to go 2 times basically, right? All right, so the first time through, return value is going to be 0 plus 2 gives me a 2. And then the second time through, it's going to be 2 plus 2 gives me a 4. And we looped it twice because there's 2 values in the array. And then we return this 4. All right, so 2 came in, 4 came out. So I'm going to maybe just keep a track of that a little bit. And of course, now I'm going to erase that because I just I want to do it again. So I'm going to write here 2 and 4. All right, let's put 3 in. So now I have an array of 3 zeros. Okay, so that's sort of again, like, okay, made a bunch of zeros, nice. Really, it seems like this is a funny way of making this loop go number times. Like instead of saying for that, count equals 0, count less than number, count plus plus, it'll go 3 times. Here we're looping over this array that was built to that same size. Okay, so we're going to go from 0, and we're going to add 3. And then we're going to add 3 to that, and then we're going to add 3 to that because we add 3 times, right? So I get 9 out. Okay, so 3, 9. All right, so there's a pattern here. We're not just multiplying by 2, we're not multiplying by 3, and in fact, we're multiplying number by itself. We're squaring it, so I picked that. All right, it took a little persistence, took a little effort, but if I just spent a little time, I'm just careful with it, I was able to figure out, what the purpose was here. So I'd rename this square. So and probably I should call it like square number or something like that. All right, well that was sort of a fun thing, I think. It was, again, a weird method, not the way you should write a square, right? It should just be number times number. But it was a way of accomplishing the task, and maybe at least seems a little interesting or unusual. All right, what are the following benefits of Java docs? Check all that apply. So again, that doesn't necessarily mean there's more than one, but it's a good hint that there's more than one thing you might be looking for. So they make it easier for others to quickly understand the purpose of your code. Yeah, I think that again is like a main point of a Java doc, right? That it's a detailed comment that describes what kind of information comes in, what kind of information comes out, and any assumptions that are there about how this thing works. So I am definitely going to pick that one. They help the computer to check whether your code is correct. Well, it might seem tempting, like, you're giving all this information out there, like, hey, I assume that, value is greater than 0 or something like that. It's in a comment. Java doesn't really do anything with that. It just is there for our benefit. It might be nice if the computer used that, and I'm sure there's some research projects that try to use Java docs to kind of, match up stuff or something. But in general, I'd say no. It's not there for the computer. Java docs can be exported to create standalone documentation about your code. Yeah, that's true. So one, it provides stuff like when you hover over things, it pops up some information. But you can also, it's nice often when you're developing, you have like a web page up with your big system, and you kind of click around these different methods and can read them. A little nicer format than just sort of raw text on the screen, and so I'm going to agree with that. And then writing good Java docs allow you to worry about fewer edge cases in your code. Edge cases, of course, are like the weird special cases kind of thing that happen, and the Java doc may explain some of that stuff, like what's allowed and what's not allowed, but it doesn't sort of prevent you from having to deal with it in your code. So I'm going to say no. And again, maybe good unit tests allow you, adapt the code and change it without having to sort of concentrate on the edge cases, because the test will tell you whether or not your method is still dealing with those appropriately. But even there, I'd say it's a little bit iffy. So anyway, Java docs are not JUnit tests, and they really are only there to help humans understand what's going on with the code. All right, so again, good to sort of think those through carefully. Complete this implementation. So usually to complete the implementation, I would say one is you can't just like hack away and do your own thing. You have to kind of follow the pattern. But what I would suggest is that the starting code is there to help guide your thinking. Like maybe this is a little bit harder problem, and it's a way to kind of force you to, or help you make progress. So let's read this thing and figure it out. All right, so returns the number of places in source. Source is a string that are a space character followed with an A character. Okay, so we're looking for words basically that start with a lowercase a, right? Because that's what a space is going to be there for. It's going to break apart words in some sentence. And again, I think it's good to kind of try to translate some sort of specific, this sort of technical description with maybe a more common sense description. And one way to do that is look at some examples. And so here we have an A with a space before it, and so we get a count of 1. It happens in one place. Here we have an A and does not have a space before it, so there's no other space, and so it returns 0, right? So the key is that it's a word that starts with A, lowercase a. So I can imagine different ways of doing this. For example, maybe if we want to use a scanner, we could actually break it apart into words that way, and then look at each one individually. But we're going to just like plow through. So what do we have here? We have a count we're keeping track of, and we have a looping over all the characters basically. Now here's the thing: we're actually starting at index 1, which is sort of interesting. And it says look backwards when you find an A. So the thing is, the way we're going to work this is we're going to search starting at 1, 2, 3, 4. When we find an A, we're going to go back and look for a space. So we're not looking for space and looking forward for an A. We're finding an A and looking backwards for the space. And I'd say either is kind of fine. One nice thing is that by looking backwards, we can there's no way a lowercase a is the very first character can have a space before it. So we're going to start at 1. And we're not worried about kind of going off the edge of the string by doing a +1 or something like that. If you want to look forward, you have to go to source length -1, so you don't jump past the end of the string when you find an A there and you look for, or you find a space there and you look for an A, you jump off. So the key here is there is a problem-solving approach here, which is we're going to look for an A and then look backwards for the space. And if both of those are true, then we're going to add to the count. So once you have sort of think of it that way, it's actually not that bad. It's just an if statement here, right? So if what? If at the source, and we're going to get char at index, if it's equal to, so we're going to find an A and source char at look backwards 1, index -1. Pick the spot before, if that's equal to space. There's a space there. Then add 1 to count. When we loop over everything, I got to fit it in here now. I'm going to return count. All right. So I'd say the key here in some ways is to try out a few ideas with some example strings, make sure you understand the problem, and then make sure your code reflects that. All right, write a method that has an int parameter and returns an int. So this is basically telling us what that first line is going to be structured like. If the parameter is less than 0, return the parameter value, otherwise return the negative of the parameter. So if it's less than 0, we keep it the same. If it's positive, we make it negative. So this is basically, I'm going to write it up here. Public static int, it returns a number. I'm going to call this make negative, and it takes in an int. I'm just going to call it val because I'm running out of space. Actually, I can keep going. I can write it out here too. It's funny. I was trying to stick to the page. If val is less than 0, return val. Else, if it's not less than 0, it's greater or equal to 0, and we're supposed to make it negative. Else, return negative val. All right. There's different things you could do here. You know, you could do -1 times val. This negative sign by itself is actually an operator. It's called a unary operator because it only has a single operand, and it operates on the thing to the right of it and makes it negative. So again, it's not like we're just writing text like -1 or something. It actually has some specific meaning here that like it's an operator, like plus is an operator, and it does something to the value on its right. But that's not really the point of this method here, right? So public static int returns an int, give it a name, has the parameter, and if we would call this like make negative of 10, 10 comes in, it's not less than 0, returns the negative, that should evaluate to -10. All right, so notice in this test there was some evaluate code, there's some thinking about things like what's the point of this kind of thing, and there's a little bit of code to write, and again, not big programs, but just enough stuff to kind of demonstrate you understand the process of values coming in and things happening. All right, so take a look at this test again, maybe do it again yourself, and I think you'll be well prepared for the midterm. Thanks.